Next is call by reference. See, if you remember, references are a nickname to a variable, existing variable. So let us look at call by reference mechanism. See, this code is for call by value only, as it is call by value code only. You can read it once. It's same. Now I will make changes in this one to make it as a code for call by reference. Let us see the changes. And the changes are very minor changes are there. See, at the place of call, we don't write anything. You remember in call by address, we were writing ampersand here, but we don't write anything in call by reference. And here in call by address, we were writing stars, but in call by reference, we write ampersands here. And in call by address, we were filling stars here. No stars, nothing, as it is. So it's more like the syntax, the way of writing is the same as call by value only the change is at the parameters we write ampersands and they become references. So the syntax is very simple, more like call by value only. But now this mechanism can modify the actual parameters. It works similar to call by address. So unlike call by value where the changes cannot be done in actual parameters, but in call by reference changes can be done in this parameter. So let us see how it works. I'll show the execution. The main function start. The moment main function starts, the variables are created for main, and this is x having value 10 and y having value 20. This is for main. Now swap function is called. This function is called, and this is having three variables, that is a, b and temp. But what are a and b? They are not separate variable, they are references to x. So this itself is a and this itself is b, and it is having temp also. So how it is possible that that function can directly access the variables of this function? It's not possible. It's not possible. Then how it happens? See, we already know that one function cannot access the variables of another function at all. But here we are saying that that swap function will call this as a and this as b. How it is possible? So when you use a call by reference mechanism, watch carefully what happens. When the machine code is generated, machine code will not be generated like this, but the machine code looks like this. Main function, and the main function is having its code, and in this place where the swap function is called, the machine code of swap function will be copied. So this piece of code is for swap function. So this means that whenever you use call by reference mechanism, it will not generate separate piece of machine code. It will copy the machine code at the place of function call. So this swap is not a separate function. It's a part of main function only. Yes, exactly. It's a part of main function. So that same part of main function is calling this as a and this as b. So there is no harm. So there is no activation record created, and actually function is not called. There is no function at all in machine code. In source code we wrote a function, but in machine code there is no function. Then what about this temp? Temp will also be created for time being inside the activation record of main function only, and this will be there as long as this piece of swap code is executing. Then it will access temp assign a, assign b and b assign temp. So the values are interchanged. This becomes 20 and this becomes 10 with the help of this temp. That's it. So this is the greatness of C++. That is, no other language is having this type of feature, that basically whenever you write a separate function, a separate piece of machine code will be generated, but in C++ that piece of machine code can be replaced at the place of function call. So when do you use a call by reference? Whenever you want the actual parameters should be modified. This is one. Second point, you should not write any complex logic inside the function if you are using call by reference. Even if one parameter is called by reference, you should be careful. Reason, this code has to be copied at this place wherever the function is called. If you call multiple times, then multiple times copying will be done. So when the code is being copied, this is the job of a compiler to copy the code there. So if the code is complex, it may not be able to do it perfectly. So usually you find warnings if you are using loops inside this type of function. When you use call by reference, avoid using loop. 1 or 2 lines of statement is sufficient. Now one more thing. I can tell you one more point here, that if the piece of machine code of a function is copied at the place of function call like this, then such functions are called as inline functions in C++. When you use a call by reference, the function automatically becomes inline function. So we also have a topic called inline functions. Separately we'll study about them. So these are the 3 parameter passing methods. I will take the same example and show you practically how they are different from one another, and also you can practice this one, and slowly we'll be using them in our programming. You will be getting more and more clear idea where to use them.